Alright, last problem here. Given a quadratic model and want to answer some questions about it. The height of a projectile can be modeled by the function h of t equals negative 16t squared plus 50t plus 10. We're told that h of t represents the height in feet and t represents the time in seconds. So, let's think about what we're going to do here. We're going to need the equation y equals negative 16x squared plus 50x plus 10, which tells me that y is the height and x is the time in seconds, height in feet. So there we go. Well, what are we going to do? So question A, what does the y-intercept represent in the context of the problem? Well, think about your variables. If it's a y-intercept, it's some sort of a parabola. It's going to look something like that. If you want to think about, let's draw a better picture than that. Let's maybe make it look something more like that. Okay? All right, so let's think about our units. X is, remember, time in seconds. Y is the height, height, E-I-E-I-O, in feet. So the x-intercept is right here at 0, 10. X is 0, so what's that saying? That's saying that at 0 seconds, the height is 10 feet. So it's essentially telling us the starting height of the projectile. So the y-intercept is telling us the starting height of this projectile. So question B says, how long does it take the object to reach its maximum height, and what is that height? So now we're finding this right here. So remember, x is going to be time, and then y is going to be the height. So when we find that maximum, the x value is the amount of time it takes to get to the maximum. The y value is the height, the maximum height that it reaches. And so we need to graph this. So enter this equation into your calculator, negative 16x squared plus 50x plus 10, and calculate that maximum. But we need to figure out where this object is going to be, aka we need to figure out a window for this. So let's think about how we're going to do that. So typically speaking, when I'm approaching a problem and I'm not quite sure what to do for my window, I start with a standard window, a zoom 6. And if you do that in this instance, a zoom 6, so that's terrible axes. Zoom 6 should look something like this. There are axes. You're going to get a graph that looks like that. It's going to cut off, and then it's going to be something like that, which looks terrible, but is actually telling you some things that you want to know. If you think about what this is saying, is like, this is our graph right there. Picture this parabola. You know it's a parabola, so it has to go up and come back down. If this is 10 right here, it looks like this x-intercept is somewhere around maybe 4 or 5. So what I'm going to do is I'm going to adjust my window. I'm going to do an x-min of 0 and an x-max of 5, and then I'm going to do a zoom fit. So the zoom button and then option 0 does a zoom fit. When we do that, we should get a much better window. And we do. When we graph this, we get a window that now looks like that. Which again, you can find a better window, but this shows us everything we need to see. So it shows us our y-intercept right here, it shows us our maximum value, and it shows us this x-intercept right there. And that's going to be important information for the coming questions. So we want to calculate that maximum value. So second trace gets you to the calculate options. We want option 4, which is a maximum. For a left bound, I would choose 0. For a right bound, I would choose 5. And then I'd hit enter, and it should take you straight to this maximum value, which should be x value 1.563, y value 49.063. So remember, this is the time in seconds, and this is the height in feet corresponding to that maximum. So it takes 1.563 seconds to reach its maximum height, and its maximum height is 49.063 feet. So let's move forward. Next question. Now, what time is the object's height 30 feet? Well, think about what that means. That's saying 30, the height, equals negative 16t squared plus 50t plus 10. So we could actually just solve this using the quadratic formula if you wanted to, but this is a calculator problem, so how I'm going to approach this problem is I've already entered my equation into y1. I'm going to enter a second equation into y2. y2 equals 30, the height that I want. When we do so, it's going to graph a horizontal line, and we can find the two intersection points. Yeah, it's going to give us two intersection points, which is telling us that this object reaches a height of 30 feet twice. So we're going to have one intersection where the height is 30, and we're going to have a second intersection where the height is 30, and we want to find those two times. So as always, we're going to hit second, calculate, intersect, which is option 5. If you only have these two curves graphed, for first curve, hit enter, second curve, hit enter again. Guess is saying, hey, put me close to the intersection point you want. And we have two intersection points. So if I hit 0 for guess, it's going to take me to that first intersection point, which happens at 0.471 seconds. And then second, calculate, intersect again. First curve, enter. Second curve, enter. Get me close to that second intersection point, which is probably closer to about 3. So I can guess 3, and it takes me there, 2.654. So we found the two times that our projectile reaches a height of 30 feet, 0.471 seconds and 2.654 seconds. So last question is, what is the x-intercept and what does it represent in the context of the problem? Well, here's our x-intercept right here. It has some x value that we're going to want to find, and then we know that its y value is 0. And remember what y represents? Y represents the height of the object. So if the height is 0, it's representing this object hitting the ground. So let's go ahead and calculate that x-intercept. So second, calculate. This time we want the option that says 0, which is option 2. Left bound, make sure you're to the left of the x-intercept. Right bound, make sure you're to the right. We know 5 is to the right. Guess should be good. Hit enter, and it tells us that that happens at 3.314. So that's telling me that it takes 3.314 seconds before this object hits the ground. Now, careful. Make sure you have some negative y values on your window. If you don't, your calculator's not going to let you calculate that 0. It'll give you an error that says no sign change. So there you have it.